Hey guys, welcome back. This is Harsh, and today we are going to discuss about trees. Not this tree, binary tree data structure. So I was going through internet and I saw this problem, which is called finding the lowest common ancestor between a pair of nodes. So let's start this problem. So first of all, I would like to relate this problem. Like, how can you relate to this problem? Is suppose somebody wants to find the 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 closest parent between two person. So what it would be? Of course, it would be their dad or their mom. So consider this problem of finding the lowest common ancestor between a pair of nodes as something like similar. So, as I mentioned, for a brother or sister, it would be their dad or their mom, and for two siblings, it might be their granddad. Correct? So, now how do we find the least common ancestor between two pair of nodes in a binary tree? So, consider this as an example. So, this is a binary tree, and each node has two nodes except the leaf nodes. And if we want to find the least common ancestor for the node 9 and node 11, what it would be? It cannot be 4 because it would be 4 for 8 or 9, and it would be 5 for 10 or 11. So for 9 or 11, the least common ancestor is 2. Is one uh, ancestor of 9 or 11? Yes, but it is not the nearest one. The nearest one is 2. The one would be the nearest one for 9, or let's say 12, or 9 or 15, or 10 or 14. So I hope I made this question clear. Now let's start. So I'm going to add a function in the class. I've created my own binary search tree. So let's start this problem. So I would want my function to return the node, the least common node, or else I can also return just the data. Let's keep it node for now. So and I want this function to return me the nearest parent in a binary tree. So what I was thinking is, how can we solve this problem? So because unlike siblings or cousins or brother and sister, we cannot just traverse from the leaf node or the child node. In tree, we can only start the traversal from the root node. Correct? So definitely we need to pass the some node which would be the root node, and also we need to pass the uh, let's what say the node which we are trying to find the common parents for. Correct? So what I want to do is here is in this function which finds the least common ancestor. So I will just uh, need the head node. Then I would need, let's just pass the data for the node, and for the second pair I'll use data 2. I can also pass node, but let's keep it simple and just pass the values of the two pair whose common ancestor we want in return. So now how do we do that? How do we find the uh, common ancestor for data 1 and data 2, these two nodes? Okay, so what I think is we can start with tracing the path from the root to the first node, and then from the root to the second node. It's like tracing your family chart from all the way to your grandfathers and their fathers down to you. And if we create the similar chart for both the pair of the nodes, or let's say children, so you would be able to find the common path, and then we can probably find the least common ancestor, maybe the most oldest ancestor, anything in that. So first our problem is find the, or let's say trace the path for first node. Then I want to trace the path for second node as well. And once the paths are traced, once I have those paths, I would then just backtrack that path and find the least common ancestor. So for that, what I need to do is uh, I need to first of all create a to hold the path. I need some data structure which can hold the path from the root to the child. So I think I can use stack here, stack of nodes. I will give the name st1, as this is going to contain the trace path for the first node. And similarly, I am going to create another stack st2, which is going to store the path for the second node. What I want to do here is I need some function to fill this stack, correct? So let's create a function. Let's call a function first. Uh, it could be trace path from root. The first thing I want to pass is, of course, the stack, which would be storing the all its parents node. Then second, I need to pass the head node of the binary tree where we are going to perform this operation. It would be head. And third, I need to pass the data actually which we are trying to find in the tree. Let's say it is data 1. So once this function, which is not yet created, but once this function will create this function, it should return the path for the first child in st1 in this stack. Similarly, I want to do something same for the second child, and this way we will have two stacks, and on the top of those two stacks we will have our data 1 and data 2. So after this step, what do we want to do now? We want to find the closest common ancestor. So what we do is we create a while loop. While our first hack count is greater than 0. Now we want to keep popping the nodes and compare if they are same for both the nodes. For both child, then it is our closest ancestor. Okay. So before doing that, because both of the stacks would be containing our data first, so we should pop them once so that We don't need the child now. We already know the st1 is for the first child and st2 is for the second child. So popping the first element would remove both the child from its own stack trace. And similarly, I want to pop the top node of the second stack. Okay, and once that is done, I will just check if let's keep the variables. So this way would be storing the top of both the stacks in parent 1 and parent 2, and if parent 1 dot data, because remember we are storing the nodes in the stack, matches the parent 2 dot data, then we can just break this loop. Our work is done, and we can print, and we can print least. I don't like to type much. So LCA for data 1 and data 2 is parent 1. I can also use parent 2 because basically they both are the same, so it won't make any difference. So yeah, once that is done, okay, I'm missing that. So yeah, it will this loop will check if there are some elements in our stack, and it will continue while the stack is not 0. And we are popping the parents from both the stack, and then we are checking if the data matches. Then we know that the parent is same, and we need not do any more thing. Okay, I'm doing this wrong here, because after this break it will come out of this loop and it won't print this line, correct? So yeah, I need to place it here, and here I won't have the access to parents, so no, so it should be something like this. Okay, uh, the C# will keep us throwing the error because we are trying to use the unassigned local variables. So for the sake of this, I will assign null value to both of them. So yeah, this way we will conclude this least common ancestor. Now only one thing is left, the most important thing. How do we trace the path? So for tracing the path, let's create one more function. Let's keep it protected this time, because we really uh, don't want anybody else outside this class or its derived class to access this trace path method, correct? So trace path is returning nothing. It will be void trace path. We are passing this tag, so it would be ref of type node, I guess, correct. second we are passing the head, and third is our actual data we are looking for in the tree. Correct? Yeah. So now we just need to fill the stack and trace the data from the head node. So we need to check if head is null or not. If equals null, then there's nothing we could do else. And stack dot push this parent. Correct? Now we check if the current node's data matches the data we are looking for. Then you can just print node found. But if it is not the case, if head is not the node we are looking for, then either it must be on its left side or on its right side. I will just check for that. If data is smaller than head dot data, then what I need to do? I need to call this recursive function again to give me the to trace the path from this current node. What I will pass? I will again pass the stack as a reference parameter because I don't want to lose the node which I have just pushed in it. And second parameter would be the head dot left because the data is smaller and we are looking in a binary tree, so it must be on the left side, and the data which we are looking for. And else what we do? Else we trace the data on the right side of the tree. Yeah, that sums up the trace path find from root thing, and by the end of this function we should have all the nodes uh, which led to our child node. Okay, so because we are pushing the head, and suppose it goes and the first element is the head node, we will have that in stack. Else we will again pass this stack onto the left or the right child, whichever child uh, uh, whichever subtree we are going to find the data in. Okay. Okay, we need to return the node as well, guys. Cool. Let's call this function from our main method now. So I've been doing some other operations. I added few elements and doing some BFS and DFS. Let's call a function now. So the name of my tree here is BT, which stands for binary tree. Not find least common ancestor, and I need to pass the root node and some data. So let's choose any data. Let's find it for 4 and 7. Okay, guys. We can pass node here as well, but I just wanted to keep it simple. Hence, I'm just passing the value which I'm uh, which I'm inserting in the tree. So yeah, we are here. This is a binary tree. The top is 7, and I guess we have 4 on the left side, and the second we have passed is 7. Okay. Yeah, since our tree is the top node is 7, I don't think this is a valid input because we are going to find the common ancestor between two distinct pairs, not between a parent and a child, because that would be like the parent is itself the the most nearest person. So yeah, change this. I guess I should change this to, or should I change this to? I should change this to 20. So the top is 7. We are looking for, and 4 is not there, and I must guess 20 must be on the right side of the root node. Where is the 20? 20 is here. See, so ideally uh, it should return 7 because 7 is the common ancestor between 4 and 20. Let's see if it does that. Hmm. Load 4 found, node 20 found, LC for 4 and 20 is 3 dot node. Okay, I think I had not. I should be doing this. I was just returning the node, and hence it was showing us that. Let's run the program once again. See, 7. And this way we can find the least common ancestor in a binary tree. Thank you guys for watching, and if you have any questions you can leave those in comments. I will reply as soon as I can, and thank you.